Hi everybody, John. What I'm showing you here is a lead zinc cell in a sodium carbonate solution. You can see where the current is here, 10 mils. See where the LED is. But what I want you to see is this. Watch close. I can't freeze this. But it's stepping, and what's charging this battery is the return pulse from the oscillator, and then it runs out like this. And it's very interesting. This is way below the trigger voltage of the transistor in this oscillator. So what's running it? Because if I disconnect it, this will go out. So I'm going to let it run a little bit longer, and I'll be back to show you what it is. So anyway, I'm back after this time here, and you can see that the voltage is 0.483. But all along here, if you look real close, if you could get it to open up here, you can see it stair-stepping all along with the voltage. And what's happening is the oscillator is recharging this cell and keeping the light on. So Fausto's experiment is absolutely right, where he's telling you that he sees a recharge condition in these cells. And it just happens to be these type cells that use the lead, the two lead plates, the alum. Seems to be with alum and sodium carbonate. This is a mixture, but it's liquidy. And that's what's running the cell, because I would almost bet if I disconnect the oscillator, it will never come on again, because the trigger voltage is way too low. So it's running itself. I'm going to let it sit for a few minutes here, and I'll be back. So anyway, I'm back. You can see that this continues with this carbonate, liquid carbonate cell. That's lead zinc carbonate is what this cell is right here. Now, watch this. I'm going to take it out. And then I just went to start it, and you see there's no current, so it was running itself. It's exactly what Fausto's talking about. And look where the voltage is. It can't run the oscillator there. And no current whatsoever. So now I'm going to go ahead and put a charge on this cell, just to show you that Fausto's right. These things run themselves. Make no doubt about it. What's going on here, because you saw it disconnected by me. Now I'm going to put a charge on the cell and show you. I'll be back. What I'm doing here is supplying a small amount of current, 600 mils at 1.3 volts, to this lead zinc carbonate cell. This is, as I said, a mixture of alum and carbonate. And I'll be back because my battery's going to run out. Alright, I'm back. Now, I'm going to rehook this up for you. What I did was I applied a small charge to this battery, just a couple of minutes, and what I want to do is show you that there's your oscillator, there's your current, and there's your light. Now, this is where we disconnected and it just ran itself, and this is where the battery is now, 0.788. Okay? Now this is just showing you where the energy is. And the energy to keep this going when this is completely dead with the alum and the sodium carbonate is coming from the oscillator. That's what's keeping it running. So, where is the energy? I'll tell you where. It's in the oscillator. Because I turned it off in front of you and it wouldn't start, but yet it was running all by itself at about 8.5 milliamps. So it was generating 8.5 milliamps, which is more than enough to keep the oscillator running. And it's the high spike that kept it running. And that could have been, that was seen when this is expanded. Kind of hard now because the scale's switched on me. Let's go back and okay, it's not going to come back up, but this is where the battery is right now. So I'll repeat this for you again. We'll take this down below, we'll let it run itself, and then I'll disconnect and it won't come back until you reverse charge on this battery. Same is going on with the lead battery, same thing's going on with the crystal cells, with these oscillators. It's just people don't see the small effects. Thanks to Fausto pointed that out to everybody, that he thinks, but it could be the trigger pulse that's doing that. Recharging the battery, battery acts as a capacitor, runs this, recharges again, does the same thing over and over. So we'll wait until this goes down, I'll be back. Okay, Chuck is taking apart the experimental cell. Point out what you're seeing there, Chuck.
Okay, well, what we can see is you got your zinc on this side, and the lead, this was a regular gray plate. It was a negative plate in one of the gel cell batteries we took out. And just overnight with the carbonate, using it, you can see it turned to, I'm guessing that's the lead monoxide.
Yeah,
is that what it is? Lead
monoxide.
It's a kind of a brown lead, it looks like. On there. And where the electrolyte carbonate was sitting on top, you can see it changed that to a kind of a weird color in itself. This insulator is just one of the ones out of the old Willard batteries here.
Yeah, that's because this changes from zinc.
And you can see it on there too, it looks like.
Yeah, changed color on you.
Yeah, and it's gotten really hard to crystals. You can really feel the crystals on them too. And you can see the lead there, it kind of turned it brown too on there. But I guess that's the effects with the carbonate, with the zinc and the lead.
Yeah, and this is the oxide. This is not, here, it's not any pitting or anything, right? It's just an oxide layer.
Yeah, just an oxide layer. It's still real smooth.
Yeah, there's no degradation in this type cell. Doesn't seem to be. And that's with alum and carbonate. But let's just try straight carbonate now, and we'll keep going.
Alright.
Okay. Anyway, we're down to 6, so I'm going to let it go back down, and then I'll be back. Okay, John, back here. Remember, this has been about an hour and a half on this charge. Started here. This is where I stopped the first time and showed you that it was running itself all in this range here. and now it's running itself in this range from about here to here. And so it's just running by itself right now, and you can see it's just a little under 10 milliamps. And this, once again, is a sodium carbonate alum lead zinc battery. It's in a liquid, you can see it here. So again, I'm going to point out that when I disconnect it in front of you, this will not start again because it's running itself. It's sending a pulse, battery responds to it like a capacitor, comes back, runs the oscillator, and it keeps going back and forth like this. So we'll give it a few more minutes for this to drop a little bit lower. And what would happen if I let this go is it would just continue. It would just continue to go if I didn't turn it off. I'll be back. I'll show you something else here.
Hi everybody, Chuck and John here. Okay, what we did is we took a zinc plate and one of the negative gray plates, and we ended up forming it in alum and sodium carbonate. And you can see that this on the edges is the brown lead monoxide, and then the white on there. Couldn't even sand that stuff off once it was on there. And earlier in this video you'll see what the plates look like. What we did is took it apart, reformed it just using alum water only, charged it, and you can see that's on a 10-minute charge, and you can see it's not dropping real quick, pulling about 28 milliamps on that. On this oscillator here, it's running pretty good. Looks like the battery's about ready to die, so we'll get back to you on this and report some further findings on it. Thanks for watching. Chuck and John back again. Had to charge the camera battery. Okay, so we're back here with this lead and zinc cell that we made, and it's still running good. Been running about a half hour or so, and if you look at the voltage here, it's kind of starting to stabilize. It's not going down as quickly. It stabilized about 20 milliamps. I tuned the oscillator to this circuit. It's just an experiment we wanted to try with the lead and the zinc, and we figured since we had already made the lead monoxide on there and the zinc had tarnished a little, it didn't have any pitting at all, it was just discolored a little bit, thought we'd give it a try with just an alum solution and a 10-minute charge. So this is where we're at on a 10-minute charge, and they said it's been running about a half hour now. So thanks for watching, and we'll report back on it.
Okay, back to this one now. We're at 4.86, which is below the trigger voltage of this oscillator. Once again, I'm going to point that out. We're at about 9 milliamps almost. This is the same cell Chuck just showed you, except that this has got sodium carbonate and alum mixed together after the exothermic reaction. So that's the liquid. The paste we don't use, just the liquid. And this is running itself, because there's no way that this is going to keep this oscillator running. And you can see it's definitely running, and it's drawing current. So once again, I'm going to let it drop just a little bit more, and then I'll be right back. Okay, back to this again. Okay, we're at 485. It's running itself, and it's almost just sitting almost dead at 9 milliamps. This is something that I want to explain to you. Alum, ammonium alumina silicate, has the power to work with most metals, and it's a unique compound in what it can do with energy. It can sit here and take the charge this direction and then give it back the other direction so that the oscillator can fire. Now the oscillator is running at about almost 18 kilohertz, so it's pretty quick back and forth here. And so what I'm going to do is disconnect it now, and we'll see here. Okay, it's not quite on its level yet because it came back on. So we'll get just a little bit more time so you can see this. I want to repeat this again for you. I'll be back. Okay, we're not quite ready yet because we're not quite at the same level there. But I want to show you something here. I'm going to make sure that it has nothing to do with heat. See, because the temperature changes in the building during the daytime. So I'm just heating up the solution. There's your voltage. So it's pretty stable solution under heat, and that's quite warm. And it's sticking around here. It maybe moved up 1,000. And that's what I wanted to see. And I'll be right back. Okay, let's see where we're at here. We can see right here. It's kind of hard to see. It's gone down, then it came back up, and then it's gone down, and it came back up. And we're at 0.48 with this carbide zinc battery. It's lead and zinc and a carbide mixture with an alum. So let's see what this oscillator is doing now if we disconnect. Now you can see that this battery is charging itself here, right in this area right here. It's on the uprise here, here it's down, here it's up, here it's down, and it's up all the way along here. And this is the scale where we want it to be, where it starts to run. Somehow there's an effect that takes place at a certain level here, where it just runs itself. But if I don't get going with this, it'll be another day video. So I'm just going to let it sit, and I'll be back.
Hi everybody, Chuck and John here. Okay, here is a new zinc and lead cell. What I did is I got zinc on the bottom of the plate, lead, and the zinc again. And you can see the voltage here. I charged it for about 5 minutes, discharged it, charged it for 15 minutes, and it started out at 2.4 volts. And you can see it's not moving too fast. And we're pulling 70 milliamps right now on this oscillator, and John will show you over here. This is a rather bright light. We've been running it about 10 minutes now. And
what's the coil? 200?
That's about 600 turns on that coil. Hi everybody, Chuck and John, we're back. Sorry, the memory on the camera is full. So I decided to take a break and reform this. And if you look at the temperature on the gun here, the ambient temperature is 73 in the room. And the more amperage I put to this thing, the colder it gets, or holds real steady at the cold. And as you can see over here, not afraid to put some amperage to it. This is only the second charge on it, because this thing, it doesn't mind, bubbles a little bit, but stays nice and cold. And we're going to go back over here, and I'm going to show you the oscillator and continue on where we left off over there. Okay everybody, Chuck and John back again here. Just took this cell off the charger and just wanted to show you what the voltage is. Settles in right about 2.4 here, it looks like, right in there. So we're going to connect the oscillator here, and you'll see it'll draw about 75 to 80 milliamps on that. And look at the voltage, and see it's not in too big of a hurry going down. Once again, we got some good light. And if you look at these plates, once again there's two zinc plates. They're very shiny. A couple years ago I did some experiments with the zinc and the alum. I never posted anything. But the alum seems to protect the zinc pretty good. So we decided to try this experiment without oxidizing the zinc first, and it looks like it's got a pretty good standing voltage. As you can see there, not moving down too fast, and that's a pretty good draw on it, 70 milliamps. Anything you want to add?
No. We'll go. I'm still waiting over there for the carbonate, the alum carbonate, to go down to where I can show you where the oscillator is running itself without the battery doing it. It takes a long time to do this. This will probably be a 2-day film, so hold on. Alright, anyway, we're just down below that line now, about where we were here. 480. And when you get to a certain point with this that the battery can't supply, it's not very much. It's like probably 8 3/4 milliamps there. But let's give it a try. There you go. Yeah. No, not quite yet. Sorry, Fausto. We have to go down a little bit lower for this to show up, and I'll be back when it can do that. Alright, we're sitting here at 4.67, and I want to disconnect this. And there you go. So it was running by itself with the oscillator as soon as it reaches that voltage. So whatever's running the oscillator is something to do with this cell. And so now what I want to do is I want to take the load off it completely, even though it's not showing a load, because it won't. Okay, so I want to do that, and then I want to see how it recovers here, if it recovers at all. And it looks like it is. Yep, here it comes up. So see, when it comes back up here, it should run the oscillator with no problem at all. So let's go over here and wiggle it around. Actually, I don't have to do anything. I want to see if it comes up here, and it's coming up. So I'll let it come up just a little bit more here. And of course there's a little notch. This scale is flipped on me, so it's up to the 1/2 volt level almost now, and they're about 90, and it's coming up. See it? So now it should run the oscillator again. Let's see if it does that. And there we go. It comes back brighter. And it comes back about the same amount of milliamps. So I just wanted to show you this. And if I didn't have this rubber band on it, I would move this outfit. You can see that the zinc changes color, forms an oxide of zinc, and that the positive lead plate forms lead monoxide. And now we'll go over and have a look at Chuck's again, and then I'll stop this film.